All right. Explanation's important in a lot of things. Teaching, learning, not just in school, but at work, in life. We explain things to different people. It's part of communication. Um, Friends, you want to explain something, explain what you're doing, um, why you're doing, who you are, why you did what you did, why you want everyone to make the choice you're making for some group activity or whatever. How people can do better, why you recommend something in fitness or diet or sport or fun or recreation. Um, and at work, got to explain things a lot at work, um, to other people, to clients, to bosses, to people who work on your team under you. Important. We can learn from Richard Feynman about this. So it goes for everybody. We all are teachers and learners in different ways. Not necessarily as a profession, but we all have to do that. That's one function we all have in our lives in society. So here is some good food for thought by Richard Feynman, Nobel Prize-winning physicist. He wrote this short story called Judging Books by Their Covers. I forget which group of writings this is found in. He wrote a bunch of books. For example, one called Surely You're Joking, Mr. Feynman, about, anecdotes in his life. So in this article, he was picked out, got a call to be on the State Curriculum Commission in California. And that would choose new books for the state of California. He did some math, and then he didn't like a lot of those. Then he was helping with some science books. He thought those might be better, but no. And this is in the 60s. Not that things are better now. Just because we are later in time doesn't mean things are improved epistemologically, educationally, ethically, or anything. We got to be careful about that. But he says, I thought maybe the science would be different, so I looked at a few of them, quote unquote. Okay. He didn't like these. It's like he didn't like the math books, because I'll go into that some other time. But he had said, quote, the same thing happened. Something would look good at first and then turn out to be horrifying. For example, there was a book that started out with 4 pictures. First, there was a wind-up toy. Then there was an automobile. Then there was a boy riding a bicycle. Then there was something else. And underneath each picture it said, what makes it go? Unquote. Okay, and then he's going to talk about how to do things correctly. But he looked at that one page where they're the pictures. Then he says, quote, I turned the page. The answer was, for the wind-up toy, energy makes it go. And for the boy on the bicycle, energy makes it go. For everything, energy makes it go. Now that doesn't mean anything. Suppose it's wackalixes. That's the general principle. Wackalixes make it go. There's no knowledge coming in. The child doesn't learn anything. It's just a word. Okay. I'll go ahead and read this part next. So, quote, what they should have done is to look at the wind-up toy, see that there are springs inside, learn about springs, learn about wheels, and never mind energy. Later on, when the child knows something about how the toy actually works, they can discuss the more general principles of energy. It's also not even true that energy makes it go, because if it stops, you could say energy makes it stop just as well. What they're talking about is concentrated energy being transformed into more dilute forms, which is a very subtle aspect of energy. Energy is neither increased nor decreased in these examples. It's just changed from one form to another. And when the things stop, the energy is changed into heat, into general chaos. But that's the way all the books were. They said things that were useless, mixed up, ambiguous, confusing, and partially correct. How anybody can learn science from these books, I don't know, because it's not science, unquote. In case people didn't quite get that. Richard Feynman, Nobel Prize-winning physicist, knows a little bit more about science than some other people. More of an independent thinker. Some people get a PhD in science, but they're just second-handed. They do not think for themselves. They don't look at the big picture. They can do their science, but to get out of what they do and to see what science is, like a physicist looks at physical things. A chemistry learns about chemical things. And they can learn some methods and some things, but they are not qualified to talk about what science is until they step out of it and see these things are sciences, and science is different from this other kind of mental functioning. And the person most able to do that would be an epistemologist, someone who studies logic, thinking skills. Epistemology includes logic, but is broader. An epistemologist would be a scientist of reasoning and logic and science. To do this well, one must be a scientist of science, not a scientist of material things. But Feynman, and he made some mistakes. He was wrong on some things, like everybody is. He was more of an independent thinker, so got more stuff right. But, as he says, quote, how anybody can learn science from these books, I don't know, because it's not science, unquote. And that's similar to what David Epstein said in his book Range, and what some people at like Gundel Bosch and Arturo Casadevall and Johns Hopkins say, and Einstein and E.O. Wilson and others. Okay, now this other part. So he talked about how to do things right and how to explain, how to develop. It's contextual. It depends on not some arbitrary word, but what your level of knowledge is and how much you've learned. Just because someone's an explanation, something is an explanation for someone in their 40s or 60s, someone who has studied physics or math, does not mean it's an explanation for someone who's younger. That's ludicrous. People don't get this because they don't get context or hierarchy of knowledge. Like hierarchy of knowledge, like white belt before yellow belt, before green belt, before red, before blue, before black, whatever the martial art is. There's some different color sequences and stuff, but you get the idea. Or having to progress through arithmetic, then algebra 2, then pre-cal, then calculus. You got to build up step by step by step. Necessary. There's some optional things we can do, but there are some necessary steps we can do. That's what the hierarchy refers to. Not some option of like this particular algebraic equation or this particular algebraic equation, but some of these linear equations in general. Get some linear before some quadratic. You don't got to learn like specifically necessarily like aqua blue or something to get color, but you got to learn some different colors. So it's based on where someone is at their cognitive level, their context and hierarchical level. That's what makes a good explanation. You got to tune in with that, with the audience, and see how they're going to build up from there. But after talking about the picture with the wind-up toy, the automobile, and the boy on a bicycle, and then something else he didn't remember, and the thing said, what makes it go under each thing? He says, quote, I thought, I know what it is. They're going to talk about mechanics, how the springs work inside the toy. About chemistry, how the engine of the automobile works. And about biology, how the muscles work. It was the kind of thing my father would have talked about. What makes it go? Everything goes because the sun is shining. And then we would have fun discussing it. No, the toy goes because the spring is wound up, I would say. How did the spring get wound up? He would ask. I wound it up. And how did you get moving? From eating. And food only grows only because the sun is shining. So it's because the sun is shining that all these things are moving. That would get the concept across that motion is simply the transformation of the sun's power, unquote. Or if it makes it clear, I'll say he was saying, so, Father, what makes it go? Everything goes because the sun is shining. Feynman, no, the toy goes because the spring is wound up. Father, how did the spring get wound up? Little Feynman, I wound it up. Father, how did you get moving? Little Feynman, from eating. Father, and food grows only because the sun is shining. So it's because the sun is shining that all these things are moving. That would get the concept across. So again, quote, that would get the concept across that motion is simply the transformation of the sun's power, unquote. Okay, as opposed to this, like, silliness. There needs to be a domino discussion. One thing falls into another, onto another, onto another. One thing makes another thing happen. And you got to get the little pieces individually sometimes. Learn that you eat and you feel warmer or you get more energy. People have to have experience with winding things up and the toys move and all that. Then you can start to add the sequences together to get a longer one. Place them together. So there is what a good explanation is. It was at Little Feynman's cognitive level where he could mentally grasp the sequences instead of just some arbitrary energy thing. Or like he'd be saying Martians make it go. You know? Energy is meaningless and it's a like logical crime or fallacy to teach it to kids that young, use the word as if they know what they're talking about. Zero clue. It's got to come later. It's a more abstract concept. Force, acceleration. And then later on, there's a need for the concept of energy with like potential energy and kinetic and chemical and stuff like that when you're looking for like transformation things. But you got to get this stuff first. And again, you can like, no need to talk about it just because someone feels all smart or because it's an abstract concept. Doesn't mean it's appropriate to use it at that level. You know, just talk about the things going in transformation and they can get the concept of energy level later. I mean, how often does it come up in life anyway? People need to see cause-effect relationships, how one thing leads to another, so they can do better at every life, which is a point of like an education or some physics anyway. If you do this to your tires, what's going to happen to the rest of the car? If you got not enough air in the tire or too much, how does that affect drivability and control? How does it affect it when it's raining or when it's dry on different surfaces? And if the tires aren't working right, how does that affect steering and transmission and costs? People need to be able to think through things like that. What the hell does energy do? You learn it, it's a meaningless word. How does using a meaningless word help you do better at work or drive your car? None. Okay? Not good education, not good explanation, not cognitive, not helpful, not rational, not logical. But that's something we need to learn. You know, this stuff was not like obvious to me from the get-go either. We have to learn, process, share, communicate, discuss, make ourselves better. It's got to be inside us first so we can explain it and understand it and help others understand it to make the world better. But this, I'll put a link to something we should read and study and try to get other examples of so we can see what a good explanation is. We need more than one example to really start to get this idea. Get examples of at different levels. What's a good explanation for elementary, junior high, high school? When can you discuss something or tell how something goes? Like we could talk about when people know some physics, I can help get some ideas of what's going on with, let's say, like impulse, energy, force, stopping force. I'm kind of tired and brain dead, so I'm being a little stupid, but what? Force or work is force times distance. And so we do some, you could talk about when catching something at a certain level, you get to say, don't just catch it like that and make a big noise. Take more time to catch it, or take a longer distance to catch it. I mean, who doesn't quite get that? Or think about being quiet. Try to jump and land quietly, or catch something so it's quiet. That's something that a young kid could start to think about and practice and understand. Anybody could. It's on a basic level. A simple way to explain how to catch things well, or how to land well. Then it's efficient and effective, and you're not smashing your feet or your hands and causing a lot of damage. I mean, there's not so much damage, but it's more efficient and everything to catch when you take more time. Take more time to catch it, or more distance. Bend more when you're landing. Instead of keeping your legs straight, take more time. But at a more abstract level, a way that no kid could ever understand, unless they're like a super genius or something, work is force times distance. So let's say you got to do a certain amount of work to catch something, to like stop it. And so if you increase the distance, then the force can decrease. There's that offsetting thing. You can explain it kind of like that. You know, if this is a constant, so when this goes up, this goes down. Simple. When you take more distance, less force. It's easier. The work is the same to stop it, but the force can decrease. And similar with impulse, what, force divided by time, I think. I forget. Times time. I'm too tired. But that right there is another way. It shows like more abstract and simpler ways to talk about the same thing. Then we're learning how to explain better. We have more examples besides this one, that very good one that Feynman discussed. So we should look at the level of the person, the audience, what they know, and what we can connect something to, what kind of connections we can show, how many they can deal with at a time, how long the sequence, whether it's springs or energy we can talk about in their context. So let's work on that. Have better explanations, make education better. So then teaching will be better and students will learn better, and hopefully that's what we want. Students who can think better and explain to other people better. If we can think better, we can live a better life. We can help make society better, help our friends more, make a better world. That's the ultimate aim and purpose of education, not just passing some stupid test. So I'll put a link to this article. You can study it, and thanks for watching.